And about simplifying radicals. So the product property states that the square root of a product equals the product of the square roots of the factors. So that means that we can take a value and split it into the square root of each of the respective factors. So here we could rewrite this as the square root of 9 times the square root of 4. We could also write this as the square root of 36. Let me do that in a different color. So by the way, the square root of 36 is 6, right? So we're almost thinking the answer here is 6 if we were to simplify it. When we break it into factors, we can also simplify these factors, especially or only if there are perfect squares. And here the square root of 9, which is a perfect square, is 3. And the square root of 4, which is a perfect square, is 2. So the product of 3 and 2 is 6. So there's a few ways to realize that the square root of 36 is 6. Now in the future here, our value underneath the radical is not necessarily going to be a perfect square. So we will have to be able to figure out how to get factors of perfect squares from it if possible. So I'm going to skip down. I'm going to skip from different sections to just kind of keep it on one idea. So let's stay with that idea of simplifying the square root of 12. Now 12 is not a perfect square, but I'm going to think about the perfect squares that could go into 12. Now actually from here, I'm going to keep listing the perfect squares here, but really only 4 and 9 could go into 12 or be a factor of 12. We wouldn't have a factor that's bigger than 12. So do any of these factor into 12? Yeah, the square root of 4 times the square root of 3. So the goal is to get a perfect square that is a factor of this number. But then remember, these factors need to multiply to reach the 12. So the square root of 12, in other words, equals the square root of 4 times the square root of 3. We have to have the perfect square and its matching factor that multiply to 12. By the way, put the perfect square first, because the square root of 4, it's a perfect square, so we can actually get a whole number square root from that, is 2. And the square root of 3, can we break that down anymore? Is there a perfect square that goes into 3? No. So we just bring the square root of 3 down. Let's try example 1 down below. I'm going to rewrite the square root of 125. And I'm going to think about my perfect squares. What's the biggest perfect square that goes into 125? Well, 4 doesn't go into 125, 9 doesn't, 16 doesn't. Does 25? Yeah, 5 times. So I can rewrite the square root of 125 as the square root of the square root of 25 times the square root of 5. And again, I'm going to put the perfect square factor first, because the square root of 25 is 5. The square root of 5 I can't break down anymore, so I just bring it down. The most simplified exact answer of the square root of 125 is 5 roots of 5, or 5 times the square root of 5. These two values are equivalent, but this is the most simplified answer. Let's try some of that on your practice. So I'm going to list the perfect squares. So from here, let's try number 1. So we're looking for the square root of 54. So what's the biggest perfect square that goes, or is a factor of 54? That'd be 9. So the square root of 9, well, what times 9 is 54? 6. So the square root of 54 is the same as the square root of 9 times the square root of 6. And what's important about this is I've identified a perfect square that goes into 54. And now that perfect square I can actually square root. Now this is not a perfect square, nor do I see a factor of 6 that is a perfect square. So I just bring that down. There's my exact answer. Let's try number 3. Number 3 is I'm gonna show you this a couple different ways. Now some people will say, so I'm going to do this two ways, hang in there with me. Some people will say, well, 4 goes into 72, which is correct. 4 times 18. So we could write this down like this. Or if you take your time, so 4 goes into 72, 9 is a factor of 72, and so is 36. If you take your time and find the biggest perfect square that is a factor, I don't know what I just did, a factor of the value, you're going to save a ton of time. So I'm going to rewrite the square root of 72 as instead the square root of 36 times the square root of 2. There's my biggest perfect square. The square root of 36 is 6, and the square root of 2 I can't simplify. That's the best answer here, folks. Well, let's go back to that first way, the student who kind of hustled through, found the first smallest perfect square that goes into it. Let's try to simplify this as fully as possible, or as completely as possible. So the square root of 4 is 2. The square root of 18 is not a perfect square. I can't get a whole number out of it, but 9 goes into 18. So I can rewrite the square root of 18 as the square root of 9 times the square root of 2. And because the square root of 9 is 3, I can rewrite this as the whole number 2 times now the whole number 3. Now the square root of 2 I can't break down, so I just bring it down. 2 times 3 is 6, and I drop down that square root of 2. So folks, while we were excited to be at this point right here, almost thinking maybe our answer is 2 times the square root of 18. That's not completely simplified. That's not going to be a final answer. It's not correct because if what the number in your square root still is still has a factor of it that's a perfect square, you need to keep going. So this is the final answer. Whether you want to do that this way with the black ink or this way with the green ink, it's up to you as long as you get to the right final most simplified answer. The moral of the story here is if you take your time and find the biggest perfect square, peel through these, get the biggest one, it's going to save you quite a bit of work. Look how much less work this took by investing a little bit of time up front. Next, let's go back and try when example number 3. So you can multiply whole numbers together. We've been doing that forever. We can also multiply square roots with square roots. So this would equal the square root of 16. And then you try to simplify that. That's 4. There's an example below that. Is that going to help us? No. So let's try that over here. Now these will be a little bit tougher perhaps. So here, number 11, I can multiply these together to get the square root of 10. Here I can multiply these together to get the square root of 54. However, you can break that down and simplify that similar to what you've done up here on 1 through 10. On the back, let's take a look at number 13. So this is like a -1. So we have -1 times, now we can multiply square roots together. So the square root of 6 times the square root of 6 is the square root of 36. And the square root of 36 is 6. So we get -1 times 6, and that's -6. Here we have like a 1 out in front. I'll go to number 16. We have a -1 out in front, and we have a -3 out in front of the other value, the other square root. So here we can multiply whole numbers together. So I'm going to rearrange this. I'm going to put the whole numbers out front, -1. This is all multiplication. I'm going to take the other whole number and pull that out front, times the square root of 5, times the square root of 5. So the whole numbers here multiply to +3, and the square root of 5 times the square root of 5 is the square root of 25. So now we try to simplify that radical. The square root of 25 is just 5. So final answer is the whole number 3 times the whole number 5, which is 15. Bada bing, bada boom.